Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing systems of equations, specifically how we can write them from verbal descriptions or word problems, and we'll do it in 5 minutes or less. So we have a sample word problem here. We've got some marbles in a bag. Some are small, some are large. We know what the combined diameter is, and then we need to write a system of equations that can be used to find x, the number of small marbles, y, the number of large marbles. Well, let's go back to our problem right here because all the information we need is actually up here. The only thing we need to get from that bottom section is what's x and what is y, small and large. All right, so we've got 42 marbles in a bag. And what do we know about those two types of marbles? Well, they're either small, that's the x, and then they're either large, right? That's the y. So our first equation that we can write is going to be very, very simple. The number of small marbles is x. The number of large marbles is y. So if you add up your large, you add up your small, guess what you're going to get? You're going to get the total number of marbles. And what do they tell you? There are 42 marbles in a bag. So sometimes the first equation in a system of equations is going to be pretty simple. What we're looking for is we are looking for a solution. So if we were to graph this, a system of equations might kind of be like this, right? It might be something to where you've got two lines, and if you were to graph them, right, you're looking for that intersection point. That'd be the solution to both. So I could graph x plus y equals 42. Now I need a second equation that I could graph. So we've got small marbles have a 12 millimeter diameter. So now let's talk about the diameters. 12 millimeters, 18 millimeters, and then the diameter of all the marbles combined is 576. All right, so each small is an x. So if I have 12x, that means I've got x marbles that are small, and each one has a 12 millimeter diameter. And if I add those diameters to my large marble diameters, remember they're 18 millimeters each, and y represents my large. What is my total? This doesn't help me unless I know what the total number is going to be for all the diameters combined, and we've got that, 576. So now I've got a system of equations. If I wanted to, I could put both of those in slope-intercept form, and I could graph them, and I could find the intersection point, and that would be the solution. Let's look at another example. So now we're at a carnival game, and we are getting prizes for yellow tickets and blue tickets, and we've got some different variables here. So the yellow tickets are y, all right, and the blue tickets are b. Okay, so what do we know about our yellow tickets and our blue tickets? So someone bought a $50 prize, and we've got 8 yellows, remember those are y, and 4 b's, those are b's. Okay, well that first sentence is its own equation. So we can say 8 yellows, right, so 8y, they give it to you right there, plus the 4b, and that's going to equal a $50 prize. All right, so I'll leave the dollar sign off. So there we go. 8y plus 4b equals 50, and I can do the same thing with my second sentence. Another player bought a $75 prize, 10 yellows, 10 blues. Okay, so 10 yellows plus 10 blues equals my $75. And there we go, that's our system of equations. So if I wanted to graph it, right, I could graph both of those. They're in standard form. I put them in slope-intercept, right, and they would kind of look like this, and I'd find that intersection point. And if I wanted to find a solution for both the yellows and the blues, you could also solve for one, right? So you could solve for b, right? So you can isolate the variable for b, and then you can actually plug that value into the other system, and you can end up solving for y. So there's two different ways to do it, but that's how you write systems of equations from verbal descriptions.